You were coming in just as I got your name.
Okay, thank you.
Okay. Let me start sharing my screen. First of all, let me move all these extra, toolbars out of the way. Go to your class. Today we're going to be looking at factoring. P5, which is the one that involves factoring, will be due on the 17th. We will probably be factoring today, the 10th, and Friday, the 12th. The reason the 17th seems far away is I want to remind everybody that the 15th is a holiday. Does everybody know that? There's no classes on the 15th. It's President's Day. And with everything that's going on politically right now, we need a day to celebrate presidents now, don't we? At least we need a day off because of the presidents. How's that sound? A little better? There will be a quiz 3, that's in My Labs. You're going to submit your work in Blackboard. It will not show up until in My Labs until after class on Friday, and it'll be due by the end of the day on Sunday. Make sure you submit your work in Blackboard so that I can give you partial credit. So the quiz will be on operations on polynomials. And we'll talk a little bit more about that on Friday. Today we're going to pick up where we left off in factoring. Before we do that, I guess I want to ask, does anybody want to look at anything in My Labs, any homework questions, either polynomials or factoring? The polynomial assignment is due today. I guess I didn't add that at the beginning. So P4 is due by the end of the day today. But now that that's stated, does anybody want to look at any polynomial questions or any factoring questions or anything from before then? The deafening silence, does that mean that right now everybody's okay and doesn't have anything that they're wondering about homework wise?
Nope.
Great. Then we left. Question? We left off, we had said that when we factor a polynomial, we want to express it as a product of prime polynomials. We had 2 ways of factoring. One was the greatest common factor, and then we looked at factoring by grouping. And so let's see, for greatest common factor, I have a question here that's sort of a make you think type of question. Let's say I ask you to factor, let's look at 10a to the negative 9th plus 5a to the negative 3rd. So let's find the greatest common factor. If I just look at the coefficients, what's the largest number? Excuse me. That's also a factor of 10 and also 5. Anybody? 5? Is there a variable that shows up in both of them? A. And now remember, with the common factor, we wanted to use the lowest exponent. So which is smaller, -9 or -3?
-9.
Beautiful. So our common factor, we're going to use the -9. And so now if I think of taking both of these and dividing them by 5a to the -9, here 10 divided by 5 is 2. Anything divided by itself is 1. Or even subtracting exponents, I get a to the 0, which is 1. Plus anything divided by itself is 1. And now for the exponent, if I subtract -3 minus -9, I get a to the 6th. And so my factored form would be 5a to the -9th times 2 plus a to the 6th. And then the other type of factoring that we were looking at was factoring by grouping. And can anybody remember what we said was going to signify that we want to factor by grouping? I think we said we were looking at something that had 4 terms. And so if I look at an example, let's say 12x squared y minus 27y minus 4x squared plus 9. And I believe when we were looking at that factoring by grouping, we said that 4 terms were too many. So we would split it up the middle. And then for these first 2 terms, I'd say, what do they have in common? What's the largest number that divides both 12 and 27 evenly? 3. And is there a variable that shows up in both of them?
Y.
So my common factor will be 3y. And when I divide 12x squared by 3y, I get 4x squared. And when I take -27y and divide it by 3y, I get -9. Let's look at the second one. Is there anything in common between 4 and 9?
No.
No. Oh gosh. And there isn't a variable that appears in both of them. So I don't see a common factor. So I'm looking for ideas.
Yeah.
Any a suggestion?
Just leave it as it is.
I'm sorry, I couldn't hear what you said.
Just leave it as it is. You just put -1 and bracket x squared minus 9.
I like, rather than the leave it is, that -1 thing. If I were to compare this factor that I have after I common factored out to this one, does anybody notice similarities between the two?
Can't you square it?
We don't want to arbitrarily square something because that's going to change the.
Don't those cancel each other out?
Yeah, aren't they opposites? They're the same numbers, but with opposite signs. So I'm going to factor out a -1. And when I divide out a -1, because these two are opposites, -4x squared divided by -1 is +4x squared. +9 divided by -1 is -9. And now that I did that, do you see now those two do match? Those two are a common factor. So one of my factors is going to be that 4x squared minus 9. And the other factor is going to be 3y minus 1. And so every once in a while, if it looks like there isn't a common factor, see if you want to keep it as it is or if you need to change the signs. If you need to change the signs to get it to match, you're going to take out a -1. If it's already the same, just put a +1 in front of it. How cool is that? So that's the type of factoring we had looked at last class. Today, we're going to look at factoring a trinomial into the product of two binomials. And when we do that, there's going to be, here's 3 cases that we're going to consider, 3 methods that we're going to consider. And the first method is trial and error. And back in the day when I learned algebra, trial and error was the way of factoring a trinomial. If you're on this math train long enough that from this class you're going to go to advanced algebra and trig, and then pre-calculus and calculus, it's worth the effort to practice your trial and error, because you get to the point where you can look at a trinomial and literally see the factors. If this is your final class, then you might prefer one of the other methods, but the other methods, you have to do a lot of pencil and paper work to support them, as opposed to trial and error, where you can eventually get to the point where you see the factors by looking. Eventually, if you are going to be taking through calculus, by the time you get to the end of calculus, it's hoped that factoring is second nature for you, not a challenge. When I factor a general trinomial, I'm looking at factoring something of the form ax squared plus bx plus c. And I want to come up with 2 binomials that are going to multiply to give me this. By the way we multiply, the factors of this the factors of the first term, I apologize. These factors are going to be the first terms in the binomials. And that last term, the factors, are the last terms in the binomial. And so when I look at a trinomial that I want to factor, I start looking at the first term. And then I go ahead and look at the last term. I ignore that middle term, because that middle term is going to come up when I check. That middle term is going to be this OI, the sum of the outer and inner, when I FOIL. So the other thing that we have to remember are our signed rules. The idea that if the signs are the same, if the product is positive, and the signs are different, if the product is negative. So what's that all about? Let's start with some simple examples and gradually get a little bit more involved. Let's start with x squared plus 14x plus 40. I start looking at that first term. In order to multiply to get x squared, the only possibilities are x times x. So when I fill in my parentheses, they're going to start with x's. Now, in order to multiply to 40, I can have 1 times 40, 2 times 20, 4 times 10, or 5 times 8. Because it's a positive 40, that tells me that the signs are the same in my parentheses. And when they're the same, they'll both be what that middle sign is. So these are both plus signs. And now from these factors of 40, we're going to guess. But we're going to try to do an intelligent guess. Which of those combinations do you folks think will give me a 14 in the middle? 1 and 40, 2 and 20, 4 and 10, or 5 and 8? 4 and 10. And this one was pretty straightforward. That's going to be my factored form, but I would always check by multiplying. I'm going to check by foiling. First, x squared, outer, plus 10x, inner, plus 4x, last, plus 40. And yep, the outer and the inner give me my 14x, and so it checks. Was that one all right? Does everybody see how we're using the numbers that we've got to come up with two binomials that multiply to give me that trinomial? Next example, let's look at x squared minus 12x plus 32. Again, for x squared, we don't have too much of a choice. That's going to be x times x. Now to multiply to 32, 32 would be 1 times 32, 2 times 16, 4 times 8. Over here, we know that the signs are going to be the same. And so this tells me that they're going to both be negative. Both subtraction. And so now, which of those combinations of numbers, 1 and 32, 2 and 16, 4 and 8, which of those do you think is going to give me that 12 in the middle?
Four and 8.
4 and 8. So I'm going to check. First, x times x is x squared, outer. 4 times negative 8 is negative 8x. Inner, negative 4 times x is negative 4x. Last, -4 times -8 is positive 32. And that does indeed give me the 12x. So this is the answer. And I have to apologize. I didn't say there's another way we could write that with the last one. We could also write that as x minus 8 times x minus 4, as long as your two factors are the same. The commutative property of multiplication says that the order in which you write them does not matter. Let's turn the page. We've done too long in one on. Next, let's look at x squared minus 2x minus 15. Again, to get x squared, is everybody all right? The only choices are x and x. This time it tells me to get a negative product if the signs are different. And so before I begin, I know that one's going to be a plus and one's going to be a minus. Now to get 15, it can be 1 times 15 or 3 times 5. Which of those combinations with different signs, one being a positive and one being a negative, do you think we could use to get a -2? One and 15 or 3 and 5?
3 and 5.
3 and 5. And which do you think should be positive and which do you think should be negative?
2. Positive 2, -5.
I think you mean positive 3, yes? And negative
Yes.
5
So,
factors. I knew where you were going. So let's check. First, x squared, outer minus 5x, inner plus 3x, last minus 15. And that does indeed give me that -2x in the middle. And so we've got it. What happens is these get a little bit more involved when that leading coefficient is not 1. But I'm going to approach it in the same way. If the leading coefficient is not 1, let's say I want to factor 6x squared plus 7x plus 2. And I have to apologize. With the others, I was a little bit lazy. Whenever we factor, the first thing that we should be asking is there a common factor? Is there any number that divides 6, 7, and 2 evenly? Anything go into those? No. So I want to look for things that'll multiply to give me 6x squared. It could be 1x and 6x, or it could be 2x and 3x. This being positive tells me that my signs are the same, so they're both pluses. And in order to get 2, my only choice is 1 times 2, because that's a prime number. Again, we're just guessing. We're looking for combinations of those numbers that will eventually give me that 7x in the middle. What do you guys want to try first? The 1 and 6 or the 2 and 3? I'm open to suggestions.
1 and 6.
So let's try 1x and 6x. Those are in the front. Now we need the 1 and the 2 to go in the back. Which number would you put where? What do you want to put here, the 1 or the 2?
One.
Did I hear a 1? So let's check. First, well, we knew the first would give us 6x squared. And actually, we know the last is going to give us the positive 2, right? That's why we chose that. But let's look at the outer is 2x and the inner is 6x. And ew, those add to 8x. Close but no cigar. Doesn't work. So let's try keeping the 1x and the 6x, and let's try reversing 2 here and 1 here. If I check, first gives me 6x squared, outer gives me 1x, inner gives me 12x, last gives me 2, and that's, ew, that's 13, not 7. I think those are the only combinations we can get with the 1 and 6. So I don't think that works. So let's go ahead and let's try the 2x and the 3x. There's still pluses. Now I'm going to ask, where do you want to put the 1? And where do you want to put the 2? What would you prefer here, 1 or 2?
1.
1. So the 2 goes here. And now let's check. First, 6x squared. Outer is 4x. Inner is 3x. Last is 2. And do you guys see we nailed it? And so this is the correct form. And so it's not always as it's obvious. I think you guys chose the 6 and 1 to start because 6 and 1 give me 7. But what we have to remember is when we do that FOIL, each of those factors get multiplied by one of the other factors. And just another hint, I know I had said, did you want to put the 2 in the first one? And this one would never work because you see over here, if I would have put the 2 there, there was a common factor. And we know there's no common factor. So we're never going to have that same number twice in the same parentheses if there's no common factor. So let's try another one of these. Let's look at six x squared minus 17x plus 12. Before I do anything, does everybody see the product's going to be positive? So the signs will be the same, and they'll both be minuses. We just looked at 6x squared. That could be 1x times 6x, or 2x times 3x. This one's a little bit more involved because we have more choices for 12. 12 could be 1 times 12, 2 times 6, or 3 times 4. Where do you folks want to begin? With the 1x and the 6x, or with the 2x and the 3x?
Let's do 2 and 3.
Let's do the 2x and the 3x. And now we've got choices on the other side. Do you want to try the 1 and 12, the 2 and 6, or the 3 and 4?
3 and 4.
3 and 4? Which would you rather put here, the 3 or the, well, I don't think we want to put the 3 here, right? Because the 2 3s, we don't want to put them together because there was nothing in common. So let's put the 3 here and the 4 here. Do you think it works? What should we do? If I check, first is 6x squared. Outer is minus 8x. Inner is minus 9x. Last is plus 12. But again, we already knew the first and the last would work because that's where we came up with those numbers. But let's look at the middle. What's minus 8x minus 9x?
Minus 17.
And woohoo, that's what we wanted. So we got it on the first try that time. Let's do one more. Let's do a couple more trial and error. Let's look at 8x squared y plus 32xy minus 168y. And again, we want to know anything in common. Is there any number that goes into 8, 32, and 168?
Yeah, 8.
8, yeah. And is there a variable that shows up in all three of them?
Y.
Y. So my common factor is going to be 8y. So that gives me 8y. And when I divide that out, I'll have 1x squared plus 4x. And I think that gives me minus 21. And do you notice when I take, if it's there, the previous ones that were a little bit of a stretch, there was nothing in common. But this one, if there's a common factor, if I recognize it, doesn't this trinomial look a heck of a lot easier to factor than the first one? We're not going to lose that 8y. It's going to come along for the ride. But now for x squared, my only choices are x times x. Then looking in the back, because it's negative, I know my signs are different. And what would you multiply to get 21?
3 and 7.
Beautiful, 3 and 7. To get a positive 4 in the middle, which do you think should go with the plus sign? The 3 or the 7?
3.
So if I go plus 3 minus 7, let's check. Checking, I want to just check on the two binomials. First is x squared. Outer is minus 7x. Inner is plus 3x. Last is minus 21. And so, oh dear, do you guys see that gives me negative 4x? And negative 4x is almost what I want. You got the right number, but just the wrong sign. all we're going to do is we're going to change the signs. So we'll keep the 8y. We'll turn that into x plus 7, x minus 3. And by changing the signs, we'll make that a positive 4x in the middle. And so this will be my factored form. Let's look at now I'm forgetting what we did. Now, let's look at 8x squared plus 2x minus 15. I should have been checking these off. We didn't do that one yet, did we? No. Okay. I'm going to shut up though. And I'm going to let you folks try this one. I'll give you a couple of minutes. Does anybody think they have it nailed yet?
Yeah, I think I do.
All right, what you got?
2x plus 3 and 4x minus 5.
And so the 2x and the 4x are going to give me that 8x squared. The 3 and the 5 are going to give me the 15. And when I check by foiling, first is 8x squared. Outer is minus 10x. Inner is plus 12x. Last is minus 15. And negative 10 plus 12 is positive 2x. And yep, that's what we wanted the middle term to be. Great job. Awesome. If you didn't get it, the idea with trial and error is to just keep on working with those factors until you do. And again, the more you practice trial and error, the easier it becomes. And not to be redundant, but if you want to get good at it, it's a phrase from ancient times, but with this one, I almost think it's very appropriate. They used to call it, when I first started teaching a very, very, very long time ago, the idea of drill and kill, the idea of practicing and practicing and practicing and practicing until you've mastered it. And again, with that idea of practicing factoring, I think showed you guys that extra handout that I put in there that has something crazy like 90 factoring practice problems for you. So, but there is another method besides trial and error. And besides trial and error, there's some people that use something, they sometimes refer it to the AC method or grouping. What I do like about the AC method is there's less guessing. What I don't like about the AC method is that there are steps that you need to follow that you have to remember. I don't know if any of you are of the age group where you might have heard something called borrow and pay back or slip and slide for factoring. But with things like that, steps that you have to remember. And if you forget one of them, you're sunk. If I look at trial and error, all I'm doing is guessing until I get two factors that multiply to what I need. And that's the definition of factoring, coming up with factors that multiply. There are no special steps that you need to remember. You just need to remember that you're looking for two binomials that multiply to give you what you want. But this AC method or grouping method, where I have a x squared plus bx plus c, the first thing that I want to do is I want to multiply a times c. Then I want to find factors of that product, AC, that add to B. Then I'm going to replace B with that sum. And then factor by grouping. Does everybody have that down? Can I look at an example, or do you need for me to wait a minute?
Okay.
I'm sorry, I heard you, but I didn't hear what you said.
I think everybody's ready, right?
Okay. All right, thank you. So let's look at that same problem. We had 8x squared plus 2x minus 15. Well, if I compare that to ax squared plus bx plus c, a times c would be 8 times negative 15, which multiplies to negative 120. So now I want to find factors of negative 120 that add to positive 2. So what type of numbers can multiply to 120? Any ideas?
Two times 60.
2 times 60. If I make that negative and that positive, that's going to add to 58, not 2. Let's see, we could have 4 times 30. If I make that negative and that positive,
Is everybody's screen messed up?
Yeah.
I think she.
Did she just leave?
I think she dipped out by accident, bro.
I think she disconnected.
So we're on this one.
You might as well leave. That's your chance to be that damn class. That's your ass ain't paying.
sorry, I got bumped. I lost my internet. I have to apologize. I don't know when you guys lost me. Did you guys get to the point -10 plus +12? Would give me that 2 that I want. Can you hear me?
I hear it.
And so since that gives me that 2, we're going to take that 8x squared plus 2x minus 15 and write it as 8x squared. And we're going to replace that 2x with minus 10x plus 12x minus 15. Now we're going to factor by grouping. These have a common factor of 2x, leaving me with 4x minus 5. These have a common factor of 3, leaving me with 4x minus 5. So the common factor is 4x minus 5, and the other factor is 2x plus 3. And if you notice, that method gives me the exact same factors that I got trial and error. It's just a matter of personal preference. Which do you guys like better? The trial and error, the guess and check, or the AC method, the grouping?
I like to try on more.
So, but both take you to the same place, and we can do them together till we're blue in the face. But really what you folks need to do is practice. There's one other type of trinomial factoring that we're going to look at, but it falls under a general heading of special cases. And the first special case is your perfect square trinomial. And I'm going to write backwards. I'm going to start at the right and work my way to the left. And that goes on that idea that we had, that if we had a binomial squared, that would be like taking that binomial and multiplying it by itself. And we had said that will always multiply first one squared, twice the product, and the last one squared. And so with a perfect square trinomial, if I start with a perfect square And if I end with a perfect square, when I do my trial and error, this is the first thing that I attempt. It's a done deal if you can recognize that as being twice the product of the roots. But just in general, if I have a trinomial that begins and ends with perfect squares, I'm going to look to use that perfect square trinomial. For example, if I have 25x squared plus 10x plus 1, can everybody recognize that 25x squared is a perfect square? That would be 5x quantity squared. And 1 is a perfect square. The signs are the same. This tells me both positive. So when I factor, I'm going to try 5x plus 1 times 5x plus 1. Gives me my 25x squared plus 5x plus 5x plus 1. Gives me that 10x in the middle. So we'll be able to say that our final answer is 5x plus 1 squared. Let's have another example. Let's say I have 4x squared minus 36x plus 81. Does everybody recognize that that's a perfect square? And that's a perfect square. And my signs are the same, both minuses. So if I try 2x minus 9 times 2x minus 9, I'm going to get 4x squared minus 18x minus 18x plus 81. And so it works. And so I'll write my answer as 2x minus 9 quantity squared. Trinomial starts and ends with perfect squares. Look for the binomial squared first. All right? So those are ways of factoring trinomials. So 4 terms, we're going to start by factoring by grouping. Trinomials, trial and error, or AC method. Always look for that perfect square factor. I'm sorry, that common factor first. But next type of factoring that we're going to look at is factoring a binomial. And in order for a binomial to factor, there's very limited number of binomials that factor. First type of thing that we'll always look for is there a common factor? And sometimes that's all we have. Other times when we have binomials, we look to see if it's the difference of squares. And if it's the difference of squares, well, that's that general pattern a squared minus b squared. And we saw that came from the product of a plus b times a minus b when we multiply the sum and difference. And so most frequently, if you have a binomial, unless there's a common factor, we're going to have that difference of squares. So let's say, for example, I have something like 36x squared minus 49y squared. Is there anything common? Is there any number that goes into both 36 and 49? Is there a variable that shows up in each of them? Thinking the answer to that is no. I've got two terms. With two terms, I look first, I want it to be subtraction. And then I ask, are they squares? Well, 36x squared, that would be 6x squared. 49y squared, well, that would be the quantity 7y squared. And so it'll factor into the sum 6x plus 7y times the difference 6x minus 7y. Next example, let's say I have x squared plus 100. Is there a common factor?
No.
No. We've got two terms. Are they squares? Yep. But is it subtraction?
No.
We're going to say that this does not factor. Why not? If I had x plus 10 times x plus 10, with both of them plus signs, I get that x squared plus 20x plus 100 when I FOIL. X minus 10 and x minus 10, I get that x squared minus 20x plus 100. In order for that to be positive, the signs have to be the same. And if they're the same, I get a trinomial. And so if I've got perfect squares with addition, it will not factor. What if instead I have x to the fourth minus 16? Is there anything in common? No. Is it subtraction? Yes. Are they squares? Yep. So let's see. To get x to the fourth, that would be x squared. To get 16, that would be 4. One's a plus, one's a minus. But with this one, there's an additional question we need to ask. Are we done? And the answer is no. Why not? Well, this one has a plus sign. And the one with the plus sign, we already decided we can't factor, even if they're perfect squares. But does everybody see this one has a minus sign, and we still have 2 squares? And so that one can be factored again. X, 2, 2, plus, minus. And so this will be our final answer. How fun is that? So 2 terms, it can be the difference of squares. 2 terms. The other way that we can factor a binomial would be if we have the sum or the difference of cubes.
The teacher left again.
She said it was.
Yeah, she left.
All right, I got $200 for anybody that did the last 3 homeworks. 200, 250 cash app. Taylor Sanders is my name. We're gonna leave it at that.